Hi, my name is Chris, and today we'll be taking a closer look at the data link layer of the OSI model. The data link layer provides the building blocks for communication across a variety of physical media. When we refer to the Ethernet standard, we are primarily looking at communications between two network interface or NIC cards on each computer. The data link layer resides in between the network layer above and the physical layer below. It connects upper layer processes to the physical layer. In a network scenario, network layer packets don't have a way to get across the physical medium. The role of the data link layer is to format these data packets into frames and send them out over the network. Also, the data link layer is subdivided into two sublayers, the logical link control layer and the media access control layer. In order for data to be sent across the network, network layer packets have to be encapsulated and formatted into frames. In this example, we'll talk about the Ethernet 2 type frame. Ethernet frames are given a header and trailer to create a protocol data unit. As you can see in the illustration, the data packet is taken from the network layer above and fitted with a header and trailer in order to be transmitted across through the physical layer and down the network. This is what's known as encapsulation. Let's take a closer look at the header. Now, the header contains information that is specific to the type of network card and protocol being used. The header begins with a start frame, which signals the receiving device that the frame is on its way. The second component is the address field, which contains the destination and source address of the frame. The type length field is used to describe what kind of data is being sent, or the length of the frame. Now, the trailer comes at the end of the frame and contains two parts: the FCS or frame check sequence, as well as the stop frame, which is optional when the field length isn't used. The frame check sequence field is used for error correction. What happens in the frame check sequence field is that the sender creates a calculation based on the content of the packet and places it in this field. When the frame arrives at its destination, the receiving computer creates its own calculations and compares them to those placed in the FCS. Once these calculations are compared, the receiving computer disposes of the frame if these calculations do not match. Once data packets are properly formatted into frames, they can travel along various network topologies that use a variety of protocols. As data travels across the network, it will encounter different hardware devices as well as networking protocols. The data link layer is not only responsible for formatting data and sending it out, but also it reads and reformats it into new frames as it crosses different devices. The data link layer is subdivided into two sublayers, which are the logical link control layer and the media access control layer. These layers provide full functionality for different protocols and hardware. The logical link control sublayer prepares the packet for transmission by giving it specific information regarding which network layer protocol is to be used in the frame. This allows for a variety of protocols to be utilized through the same hardware. The media access control sublayer regulates the placement of data onto the physical medium or network. It also provides specific information that allows the frame to meet the specifications of the physical device that's being sent across. The media access control sublayer also marks the beginning and end of a frame. When you think of the MAC layer, think of the traffic rules that we follow when we're driving on the roads. Data is placed on the network adhering to specific Layer 2 protocols, and the media access control layer makes sure this happens properly. Layer 2 protocols are chosen based on hardware implementation as well as logical topology. Examples of these protocols would be the High-Level Data Link Control, or HDLC protocol, the Point-to-Point Protocol, or PPP, Frame Relay, and Ethernet. As you can see, the data link layer gives us the ability to communicate with one another over the internet. This has been made possible because the data link layer is divided into the media access control and logical link control sublayers. The logical link control sublayer prepares data for transmission, and the media access control sublayer regulates access to the physical hardware that's being used.